All right, folks, so we are going through what should be a very quick video lesson here. We're going through it after you have gone through an exploration on page 130 of the text. And for that exploration, I want you to go from steps A through I, and that's all the steps. Once you finish that, then you're ready for this video here. Now, when we're working on this video, first we're just going to look at a few graphs to discuss what we've just learned. Then we'll talk about the rule, the procedure we can follow in order to find our minimum and maximum values on an interval. And then we'll go over just one example down here. So first of all, these three examples. Let's look at the first graph right here. A maximum value we're expecting often, not all the time, but often, we're going to be finding the maximum values over a given interval. We're going to be finding the maximum values where our function has a local maximum. Okay, and that is where our function has a turning point, where it changes from increasing to decreasing. Now we'll notice at a local maximum, the slope of our tangent is equal to 0. So right here, we notice f prime of x is equal to 0. We also notice at a local minimum, f prime of x is equal to 0. Now, that's all well and great, but our maximums and minimums over an interval will not always be at a local maximum and local minimum. So let's take a look at our second graph here. Okay, here we have our slope is equal to 0, f prime of, whoops, let's go back to that orange color. F prime of x is equal to 0 here, right at this local minimum and at this local maximum. We can see that. We can see our slope sketched in here as horizontal lines. Okay, that's all well and great, but if we're going to check to see if these truly are maximums and minimums over the interval, we need to compare with the endpoints as well, because the endpoints might not have a slope approaching 0 or a slope equal to 0, but the endpoints might be above or below any of the local extrema, the local maximums and minimums that we found. So we'll check here, and our first endpoint we can see is below the local maximum. Our second endpoint, as we can see, is below the local maximum. So that means that this local maximum is also an absolute maximum over this interval. Okay, now let's check our endpoints compared to the local minimum. Well, I can see here my two endpoints circled in green are, one of them over here on the left is less than the local minimum I have there. That means that the absolute minimum that I'm working with is not a local minimum along the graph. Okay, that means it is not where the slope is approaching 0. Okay, let's try our third graph here. Again, we're checking to see where the slope of our function is equal to 0. I can see that the slope of my function is equal to 0 right here and right there. A local maximum, a local minimum. Will I always have my slope equal to 0 at some point over an interval? No, not necessarily, but often we will. Will it always equal 0 twice over an interval? No, absolutely not. These are just, we kept that consistent for these three sketches. Now I need to compare my endpoints here and here to my local maximum and local minimums that I found. So the highest value out of each of these 4 points, right? I have a local maximum, a local minimum, and 2 endpoints. My highest value of all 4 of those points, that's my local maximum. That's my absolute maximum. That's way up here. My lowest value of all 4 of these points is going to be my absolute minimum, and that's way down here. All right, in this third case, neither the absolute maximum or absolute minimum occur at the local ones that we found here occur where the slope is approaching 0. Okay, now that means if we're going to check to see our extreme values on an interval, if we're looking to see our absolute maximum, our absolute minimum on an interval, then what we need to do is, first of all, we need to find any points on the interval where our slope is equal to 0. Because if our slope, that is, if our derivative is equal to 0, that means we have a turning point, or we likely have a turning point involved. And if we have a turning point, it means we might have a we might have an extreme value there. But we also cannot forget to check to check our two endpoints where x equals a and x equals b. So what we're going to do at all of these points where x equals a, where x equals b, and at any point where our slope is equal to 0, we're going to calculate our value for f at x. We're going to calculate the value of the function. We'll compare all of these in order to determine the largest of the values, which will be our maximum, the minimum value, which will be the smallest value. Okay, so let's say we're working here with f at x is equal to negative 2x cubed plus 9x squared plus 4. We're looking on the interval from -1 to 5. We're not going to worry about the interval quite yet because first we're going to find any values, f prime of x, any values where our derivative is equal to 0. In order to do that, we need to calculate our derivative. We're working with negative 6x squared plus 18x. Okay, if I would like, I can factor that. I don't necessarily need to factor it now. What I need to do is I need to find where that derivative equals to 0. Now I can factor it. That is negative 6x times x plus 3. Okay, well, this is going to have two solutions, right? If x is equal to negative 3 and if x is equal to 0. At both of those places, our derivative will be equal to 0. Well, that's all great, but if we take a quick look in here, oh, you know what? Sorry, folks. Let's see, we'll see if you folks caught my mistake there. We should not be working with x plus 3. We should be working with x minus 3 in here. X minus 3 in the factor, telling us that our root is at plus 3. Perfect. So moving on from here, now we need to calculate f at x at x is equal to 0, x is equal to 3, and at both of the endpoints on our interval, so at -1 and at 5. So let's try that out here. F at, and you know what, you can use a calculator for something like this. We're working here, f at 0 is equal to positive 4. F at 3 is equal to 31. You can check your own work with me right here or with a calculator. F at -1 is equal to 15. And f at 5 is equal to -21. Okay, so these are the values that we're comparing to determine our absolute maximum and absolute minimum over this interval. So all I'm doing is I'm looking to see which value is the greatest, which value is the smallest. So our absolute maximum here is going to be equal to the largest value, and that is 31. Our absolute minimum here is equal to -21. Perfect. If we're curious about it, our absolute maximum, where does that occur? That occurs at x equals 3. As I see, that's my x value, where my y value is equal to 31. If I'm curious, my absolute minimum occurs at x equals positive 5. Fantastic. So folks, you should be able to handle, by this point, all of the homework problems from section 3.2. Try them out.